Hello once again, our most valued student. My name is Confident and welcome to our revision session, and we are preparing you for the November exam. And of course, this is mathematics, and as you know, we are focusing mainly on mathematics and physical science. So this is a provincial paper, the latest November 2022 grade 10 mathematics paper 1. So I'm going to go through this paper, but it's going to be in two parts. So I just want you to stay focused. There will be part 1 and part 2. Now let us quickly look at this question and see how you could have answered it, and trust me, it will prepare you for your final exams. So they are saying here you need to answer all questions. There are 7 questions. This paper consists of 7 questions. Present your answers according to the instructions. Clearly show all your calculations, diagrams if necessary. You see all your calculations. This is very, very important. Don't forget that. All right. And then answers will not necessarily be awarded 4 marks. So if you just come up with an answer, or if you work your answer in your question paper, remember they don't give you any paper to do rough work. Usually you work on your question paper, but if you don't take that and put it in your answer sheet, unfortunately you just put just the answers, you're not going to be awarded any marks, eh? And then let's continue. The rest of the things are standard and basic. Please be neat. Don't write like you are hanging on a tree, okay? You just need to be neat. Now let's look at this question paper and see how you could have answered. Now, as I said, I want to do it in 2 parts because I just want to give you options how you could have answered it. Some prefer the other method over the other, so it's your choice. You understand? So let's start with this first one. What are we doing here? Question number 1. In this question number 1, we are factorizing. It says factorize the following expressions, but there is the key word, fully. Are you seeing that? So there it will end you what? All these marks. 1.1.1, 2, and 4. So you need to be very sensitive there. Let's start with the first one. Guys, whenever you are given a question, you need, through practice, try to see where the examiner is trying to lead you into. Remember, already these you have done in your exam, during the year. So you need to know what type of factorization is this before even you attempt it. For example, if you are going to give me this question, 2x to the power of 6, let me write neatly what's happening here. 2x to the power of 6 minus 8. You want me to factorize this, and they are just 2 terms. And mainly when you are talking about 2 terms, what comes into my mind is the difference of what? Of 2 terms. You see? The difference of 2 terms, and there is the difference. The negative sign means the difference. So what do? The first part that is confusing me there is the 2. So I need to factorize it. By factorizing it, I'm going to take out 2. And by taking out, it's more like I'm cancelling 2 into 2. And I'm getting what? I'm getting this x to the power of 6. You see? And then I'm saying 2 into 8. It's giving me a 4. Are you seeing that? So let's do that. So I've got minus 4. But I'm not going to write 4 here because I'm focusing on the difference of 2 squares. 4 is 2 squared. So I'll quickly go on and say 2 squared. Why? Because I'm dealing with a difference of 2 squares. It must be in squares. So from here, let's not waste time. If you're given it like this is what you do. You say 2, you open brackets here, you open and close. Remember, it's a difference of 2 squares. Now, when it comes to 6, you divide it by 2. When it comes to 2, you divide it by 2. Are you with me? Why? Because you are trying to simplify that in a way. So if you divide 6 by 2, what you're going to have is x to the power of 3 minus 2 to the power of 1, which is just 2. That's the first one. The second one is x to the power of 3. You don't say minus, you say plus. You say plus 2. Then you get your final answer. Remember, you have practiced this. Let me just give you a simple one so that you can remind yourself. For example, if they give you x to the power of 16 minus 2 to the power of 8. You see, this is a difference of 2 squares. So what you do, you open a bracket, you open a bracket. As I said, we are dividing by 2 by 2. You see that? So when you're dividing by 2 there, what are you going to have? You're going to have x to the power of 8 minus 2 to the power of 4, and then x to the power of 8 minus plus now 2 to the power of 4. This plus is done. This is done. Alright, but this one still can continue. It's a difference of 2 squares because there is still minus. So you divide again here by 2, divide here by 2. I hope you are following. Since you are dividing by 2, it's going to be what? You open another bracket, you open another bracket, you open the last one. And this one, remember, is x to the power of 8 plus 4. It's not a difference. Difference means minus. But here you have x to the power of 4 minus 2 to the power of 2, and then x to the power of 4 plus 2 to the power of 2. You see that? These two are complete, but still you continue there. You divide by 2, you open bracket, you open bracket. When you divide by 2, you've got x to the power of 2 minus 2 to the power of 1. That's the end. And then you've got x to the power of 2 plus 2, and then of course the last two brackets become this. You see? So guys, that is what I'm trying to bring to you. It can go on and on, but now the one that they gave, this one, it wasn't something that can continue, because already look at this, you have got 2 to the power of 1, so that's the end. So this becomes now how many marks? You get just 2 marks for that. Okay, so as I say, guys, I'm trying to bring in we're revising, but at the same time I'm trying to bring in some information that can be very, very important to you. Let's look at the next one. They say factorize fully, and this one has got 4 marks. For some reason, I just want to find out why they made it 4 marks. Look at this. It's saying 1.1.2. Let's look into this one. Alright, so what do we have? We have got minus x, alright, and then we've got that one to say x minus y to the power of 3 plus y. Okay, so now again, okay, when I look at this, I think these need to be combined. You see, these. So when I combine these, I can rewrite this to say x minus y to the power of 3. You see this? And then plus y, and then minus x. It still maintains the sign because the equal sign is this side, so nothing is jumping this side. But now look at this. You need to be very, very, look, when they give you something, when the examiner is bringing you something, there is always a reason. They have already worked this out, remember. So they just want to see, can you see what they're trying to hide? Look at this x minus y, and look at this y minus x. It's actually something this is similar. If I look at this, actually let me do it this side. Look at this. If I say y minus x is equal to, if I take out a negative, you interchange the sign, you've got minus y plus x. You see, this they might have taught you already in school, to say you take out a negative, you open a bracket. Remember, the negative now needs a bracket, but you interchange the sign. Y was positive, now it's negative. X was negative, now it's positive. You see, you didn't do anything in a way. If you open up this, negative times negative is positive y. Negative times positive x is negative x. You see, and then it takes you back to that. Are you with me? So now, when I have it like this, I can now rewrite it as like this, look, which is equal to minus x, because it's positive, minus y. Are you seeing that? This is what they are trying to bring to me, to say, look, are you able to see that this then becomes equal to x minus y cubed, right? And then minus x minus y. Sorry about this. Okay, x minus y here. Do you see now? Look, the ones that are in the bracket, this is x minus y, this is x minus y. That's where they wanted to trick you. Okay, now since this is the same x minus y, I can factorize and take out x minus y outside, you see? And then what is going to be inside? I've got, look, when I'm doing this, it's more like I'm cancelling x minus y into this x minus y. I will cancel the 3 and 2 of them will remain, you see? So that is what I'm doing. So I'm going to have here x minus y, but what? Because I cancelled one, it's squared. Then secondly, if I say x minus y into x minus y, what will I get? I'll get just the 1. So that's what is happening there. So it will be minus 1, you see? Then that's why I opened the big bracket because of that. Guys, that's the end. Then you can now say, in this case, let me just check, was it a squared or a cubed? Okay, it was a cubed. So from here, it's up to you how you want to do it. You can continue now to say x minus y. Okay, but now something is coming already in my mind to say, okay, look, this is a squared and 1 can be a squared. It's also a difference of 2 squares. You see, they are very clever. They're trying to hide it like that. If you see a square, you can actually look at it like this. If you see this x minus y, this one, you can say x minus y, let it be equal to m. So what you will have is m squared minus 1. So what is m squared minus 1? M minus 1 and what? And m plus 1. But you remind yourself that m is x minus y. So you have x minus y minus 1. You see what is happening? And then m again is x minus y plus 1. That's what they're trying to do here. So that's what you're going to write. To say here, x minus y minus 1. That's the first one. You can open that big bracket. And then the second one is x minus y plus 1. You close it. You close. This becomes the final answer. Guys, this was again a what? This was a difference of 2 squares. Of 2 squares. You need to what? Revise that. You need to revise that. You need to revise these kind of questions. That's why they made it how many marks? 4 marks. So say, if you got it right, you're gonna get it there, you're gonna get it there, you're gonna get it there, and this is 1 mark. And then what do you have in total? You've got your 4 marks. I hope, guys, this makes some sense. This makes some sense. Alright, we're continuing. It's revision, you see. I'm not in a hurry to kind of I know this is for the underdogs, by the way. This channel is not for the high flyers to say, I know guys are always saying you're too slow, you're very boring, but I have the underdogs. If I can show you the comments of the underdogs, you'll be shocked for people who say, look, do continue doing like that because we understand better. So if you feel like this is too boring for you, please, there are other channels that can assist you. Okay, 1.2, simplify. How many marks, guys? This is 2 marks. And then it says simplify the following completely. You must always look at these words. That's where the marks are. Even the other one here, that's why they say it fully. If you didn't see that there was a difference of 2 squares, you're gonna be lost. But it's 2 marks, so it's not far. Let's solve that. It says we have x to the power of half minus 3, and then what do I have? Squared. And that squared, I can just do like this. It means there is 2 of them. X to the power of half and then minus 3. Okay, and then in case you don't know what I'm looking at, 1.2.1. That's where we are. Alright, so look into this. It's just simple expansion, guys. There is nothing special here. This multiplies. It's a FOIL method. This multiplies. This one multiplies. And this one multiplies. They're just testing you, though, in a way with the laws of exponents. To say that times that, what you will have is x to the power of half times x to the power of half. That's what they're saying. And then x to the power of half times minus 3 is negative 3 x to the power of what? Of half. And then again, that times that is negative 3 x to the power of half. And then minus 3 times minus 3 is a positive 9. You need to know now the laws of exponents. Look, same base, so it's x to the power 1 over 2 plus 1 over 2. When the bases are the same, what do? You add. And then minus, this is the same as saying, if this was a and this was a, what are you going to say? Minus 3a minus 3a. You add, but keep the what? It's like this. If I give you in a calculator to say, let me just grab my calculator and say here, minus 3 minus 3. What am I getting? Minus 6, 6a. So I would have said here, negative what? Negative 6. Here, maintain my negative 6a, but my a is same as x to the power of half. Are you getting that? And then plus what? Plus 9. That's it, guys. You know, and then you simplify it to say half plus half, it's 1. So which is x to the power of 1 minus 6x to the power of half, and then plus 9. Then you can even leave the power 1 there. That's the answer. That's why this was 2 marks. And you know, you can test your answer, by the way. This is what you can simply do. You can say let x be equal to, choose any number, 13, you know, and then you take a calculator. On this what you call final answer, you put that value of 13 here. So what you do, you can say 13, where there is x, you put 13. 13 to the power 1 is the same minus 6, and then 6x, which I'll say times 13 to the power of half. Remember, 1 over 2. Are you seeing that? And then I say here plus 9. I get the answer. It's a funny answer, 0.36669. Look at this answer. Just remember, 0.36669. And then I go to the original, and the original here says bracket x, which is 13 to the power of half. Remember that? And then it says what? Minus 3. And then everything to the power of 2. You see? Same answer. It means I'm correct, because the what do you call this? What I started with and what I'm ending with is still the same. So you can just use search to quickly test if your answer is the same, if you're doubting yourself, you know. Alright, so let's look at the next one, guys. It's 2 marks again. 1.2.2. This is still exponents. 1.2.2. It says x to the power negative 3 divided by x to the power of negative 5 plus x to the power of what? Negative 2, and then here is negative 1. Okay, guys, remember you can try it first, then compare your answers. Remember, this is revision, so try it, compare, and see if ever you're coming out right. Here it's easier. We are going for BODMAS or BODMAS. It doesn't matter how you do it. It's BODMAS or BODMAS, or you know, there are different of them, but division comes first. So we are here first. And remember, with division, you apply the laws of exponents. If it's division, you use what? If it's division, it's minus. So what you're gonna have, it's x to the power of negative 3 minus what? Bracket minus 5. Are you seeing that? And then plus, now these two, they multiply in exponents. You multiply this times. Okay, so what I'm going to be having is x to the power of negative 2 times negative 1. So now when you simplify that, you've got equal to x to the power of what? Negative 3 plus 5 plus x to the power of positive 2, or 2. You can leave out that positive. So you have got, in this case, x to the power of 2 plus x to the power of 2. Now there some of you get lost. They start writing errors. You know what they write? They'll write the answer like this: x to the power of 4. You see? Very wrong. You know, if I was near you, I was gonna squeeze your ears a little bit so that you can feel some pain. You can't do that at this stage. After doing all this work, you come in and say, this is x to the power of 4. No, guys, there is a 1 there, there is a 1 there. 1 plus 1, it's 2. 2 of what? Of x to the power of 2. Okay, don't go wrong in the last step. That's what they wanted to test you on. How many are x to the power of 2? There is 1 there, 1 there. You add is 2 to the power x to the power of 2. I hope you guys are benefiting. Give me some comments as you are benefiting. All right, let's move on to the next one. 4 marks. So which means they needed a little bit of, it's actually exponents. Okay, look at this one. It's what? 1.2.3. All right, look at this. It's 5 to the power of x. X plus 1. All right, times. I can use times. I can use, actually, let me prefer to use this times, the multiplication sign on its own. And then I'll put 4x. I'm just writing it as is for now. And then divided by 2 to the power of 5x. And then minus 2 times 10 to the power of x minus 1. Okay, equal to, guys, they will never give you something that does not make sense. As I told you, they've already worked this out. It's your duty just to see what are they trying to trick me on here. So let's quickly solve this kind of error or trick that they wanted to bring. Okay, I have a 2, I can't simplify it further. I have 5, I can't simplify it further. But here I can do something. What is 4? 4 is same as 2 squared. What is 10? 10 is same as 2 times 5. You see, I have the 5, I have the 2. That's what they wanted, just to do that. After that, you work on the basis. Remember, it's multiplication, you just work on the basis. So let's do that. So what you have, you split. Okay, by the way, we are using this rule here. Actually, let's leave it like that. There is no rule actually to use. We can just leave it like that. 5 to the power x plus 1. There is no rule. We don't have to split this thing. And then times 2. Now remember, 2 squared, which is 2x now. And that x will multiply because it's more like I'm saying 2 squared bracket x. The x will multiply, and then at the same time you've got 3. So you're saying 2 times x, 2x times 3. You see, so it works. Don't let it confuse you. And then, but here I'm still gonna put that 3 for now, you know, for the next step, over 2 to the power of 5x. Remember, they said we must show some steps, so let's not cut too much. And then this is 2. Look at this. At the bottom is 2 times 5. Now I just don't want to do this many times. Look at this. It's 2 times 5 to the power, that's 10, to the power x minus 1. So you must know that this, it affects that one and that one. So I'm just going to write it now already to say here, I have here already, I have 2 to the power of x minus 1. Are you getting that? And then times 5 to the power x minus 1. Are you getting that? Then we're good to go. You take everything to the top. I repeat again, let's take everything to the top. When you're taking everything to the top, you need to be sensitive. When things are going to the top, the signs change. Remember, what is positive becomes negative. But also at the same time, when you're taking them to the top, be sensitive that you are taking to the top same basis. For example, 5 to the power of x plus 1 times, I'm taking another 5, there it is, 5. Now when I'm taking a 5, x is positive, is negative x, plus 1. You see what I'm doing? Times 2 to the power 2 times 3 there. We said it was 6x. And then I'm taking that one up, times 2 to the power of negative 5x plus 2. Look at the interchanging of signs. Please, it was a positive is negative. It was negative 2 is positive 2. Times 2, I'm here now. Positive 2, positive x here, sorry, it's negative x. Negative 1, it's positive 1. Then we're good to go. Same basis. What do? You add. So we have got 5x here. We're collecting like terms. X minus x. You see that? And then plus 1 plus 1. Are you seeing that? Times 2 to the power of 6x. Are you seeing that? Minus 5x minus x. And then on the numbers plus 2 plus 1 equal to 5. Then you can see what's happening. X minus x. So you've got 5 squared here. Times, again, look at this. 6 minus 5x minus this minus this. It gives us 0. So you've got 2 to the power of what? 2 to the power of 3. Which is equal to 5. This is 25 times 8. 25 times 8. If you use a calculator, what do you get? What is 25 times 8? It's what? 200. There it is. And then the answer becomes what? 200, guys. Can you test it? Yes. Yes, you can test it. You go here on the, let me just do this. You come here, choose any value. Remember I told you, you choose any value of x. What are you going to choose? Let's choose any value of x. Don't make it too big now because you're dealing with exponents. Let's say x is equal to 5. You see? It must give us 200. Okay? Because that's what the final answer was. So you can come here and say 5 to the power of, remember we said x is 5. So 5 to the power of 5 plus 1, play forward, times, bracket, 4 to the power of what? X is 5. Close that bracket. Be careful how you do this. See how I'm doing it. Exactly as the calculator, please. If you make errors, then that's now going to be a problem if you don't know how to use the calculator. To the power of 5, you put a bracket there now because it's 5x. 5, you see, minus 2. And then play forward because those are exponents. Times, if you don't play forward, you're going to be saying times 10 in exponent form, you see. Times 10 as a number, as a base. And then to the exponent of 5 minus 1, you see, equal to 200. It doesn't matter what number you're going to use. Doesn't matter. I can play back and say I want to choose number 7 here. So wherever there is a 5, this time I chose 7. You see? This time I chose 7. And this time I chose 7. Equal to, it will still maintain 200. That's how you can be testing out your answers, guys. Alright, so this is revision. I'm trying to show you some tricks and some strategies that you can use as you try to prepare for your final exam. I hope this is making sense. Let's continue doing some of these questions. Alright, so let's look into this. Guys. Yeah, still some work. We're still gonna do, see, there's still more work coming. Don't lose me. We're still going to go through these are equations. Don't lose me. After equations, we're going to end here. Question number 3. We're going to end here on this is sequences. So don't lose me. You need to keep focused. Okay, keep focused. There is this one. I don't know how they made it. This is 5 marks. Fractions, guys. I don't know why they made it 5 marks. So let's look at this one. 1.2.4. It's 5 marks. Do you want to lose it? No. So keep focused. Don't go away. Keep focused. Alright. By the way, when you're watching this video, when I'm saying keep focused, I'm not saying stay long watching the same video. This is called 24-minute lessons. Watch it for 24 minutes, take a break, come for 24 minutes, take a break, come for 24 minutes, take a break. What are you going to be doing when you're taking a break? Just take a walk around, go outside, totally talk to someone, do something totally different, and then you come back, continue the video. Because anything you do after 24 minutes and you try to focus and concentrate, you are wasting your time. Your mind can only focus to a maximum of around 24 minutes, 25 minutes. Hence, you see, some of my videos are just 24 minutes like that. But these ones, because we are revising, I make them long, but it's your duty to break them into parts, okay? I hope we're together. Let's continue. Look at this one. It says minus 11 all over 2x to the power of 2 minus 5x, and then minus 12. And then from here, we have got minus 1 over 4 minus x. What did I say? I told you they don't give you something that does not make sense. Whatever they give you, already they've worked it out and they're trying to say, can you see what we're trying to trick you on? Let's look into this. What were they saying? You need to factorize here, definitely. Okay, and then factorization, guys, I'm not going to be teaching factorization at this stage, okay? So I usually use product sum method to factorize this. So what is this? This is 2x squared minus 5x minus 12, you see? So some people can actually what? Can actually do this. There are some people who are able to do this, and then they are able to say, okay, this is 2x, and then this is x, I need to get a 12, and then they work it out, you know. But I'm not really good at that, so I usually use the long method, you know. So what I do is I write my product, which is equal to, I multiply the first and the last term, which is negative 24x squared, and then my sum, which is the center, which is negative 5x, and then my factors, they are the factors of the what? Of the product, which means factors of 24, which is 1 times 24, 2 times 12, 3, I need to get 24, 3 times 8, and 4 times 6, I think that's the end, 5, and 6 times 4, that's the end. But remember, when I add, I need to add this factor to give me a negative 5. So my factor is here. I don't have to think much. Guys, as I said, you need to have worked this out. So I can now come in here, erase. It's something that I do. Check my videos. I do a lot on the product sum method. So it's 2x squared. From 3 term, I change it into a 4 term, and then I group. Now, you see, here I have got 3x. Now I need a 5, so 8 must be negative. So it's positive 3x, and then minus 8x minus 12. If you look at this, 3x, 3 minus 8 is minus 5, you see? That's why I'm saying the factors are like that. And then from here, what do? I just group the first 2 and the last 2. Common there is x. And then I've got 2x plus 3, and then minus what? 4. And then it's what? 4 into 8, it's 2x, and then plus 4 into 12 plus 3. It must be the same, of course. Remember grouping? Then it's 2x plus 3, and then what do I have? I have got x minus 4. Then equal to, I have factorized. So I told you, they allow you, some are able to do this. They'll write 2x, x, and then they'll write 3 and 4 like that, you know. So even if you didn't work it out like this, they allow you to go straight like that, to say, from here it's minus 11, and what was my answer? It's, here it's 2x, you do this, and then you've got 2x plus 3, but I tell you the truth, this is what I do, x minus 4. I know I'm old school, but that's it. Now, look again at the way they did it. We have got x minus 4, but we have got 4 minus x. This is one thing. The only thing is you need to take out a negative. What am I trying to say? I'm trying to say if they say 4 minus x is equal to, take out a negative. When you take out a negative, it's minus 4 plus x. You interchange the signs. 4 is positive, now it's negative. X is negative, now it's positive. Which is equal to minus. You start with x, it will be x minus 4. You see? That's what they're trying to trick you on, to say, can you see that this is same as saying minus here, minus, and then 1 over, at the bottom is minus x minus 4. And usually when we do this, we usually give in like a big sign, like a bracket like this, so that we protect those two negatives. But it doesn't matter when you're having one at the top and one at the bottom. What it means it's a plus here. This is equal to a plus. Okay, so when you're writing it, you're going to say minus 11 over 2x plus 3, and then what you have here, x minus 4, and then plus 1 over x minus 4. You see, they are intentional the way they give. They don't just give these questions randomly. X minus 4, x minus 4. So what's the common denominator here? The common denominator is what you are seeing, which is 2x plus 3. You see, you write what is appearing, and then you've got x minus 4. You can't repeat x minus 4. It's the common denominator there. And then what you have now to what? You have to add. Remember, we're adding this. So how do you start adding this? It was minus 11, just to check again. Yes, it's negative 11. How do you add this? You start by saying, take that negative 11, and then what we are saying is, this one will cancel this one. How many times? Once. You see? So here, you are going to say 11 times 1, because that goes into that once. And then you've got plus, you write the 1 there. And then you are saying, again, x minus 4 will cancel only x minus 4. That will remain, you see. So that's what you're saying. So when you do that, we're going to say bracket 2x plus 3. That's what you do when you're dealing with fractions, you see. That's it. Minus 11, and then 1 times that is same thing, 2x plus 3. The denominator, don't lose it. Don't lose the bottom. 2x plus 3, and what is that? X minus 4. Are you with me? You continue. Equal to 2x, and then you're saying minus 11 plus 3, which is what? Negative 8. Okay, over 2x plus 3, and here x minus 4. You see? You might think it's complete, but it's not. Why? Why is this not complete? Guys, look at this. 2 and 8. You still need to factorize. 2 outside, 2 into that. You are cancelling there. You see, when you cancel there, you've got x. See that? So you've got x minus, you are cancelling there. You get a 4 there. You see that? So x minus 4 over 2x plus 3, and what else? X minus 4. You see, they are very intentional about this. You further cancel x minus 4, x minus 4, and then the final answer therefore becomes 2 over 2x plus 3. Okay, do you want to prove it? Yes, this is how you prove it. Proof. I'm not gonna do it, but this is your time. Just choose any value of x. For example, you say let x be equal to 11. Let's not use 11 because you'll say there is 11 somewhere. Maybe you just say 15. You come here, you put x is equal to 15. You go to the original here. Where did we start? We started here. Where there is x, what do you put? You put 15 squared. You put 15. You put 15. The answer you get here must be equal to the answer you get at the bottom. If those match, then you are in the right track. Okay, guys, that's how you do these things. Alright, I need to erase this, so let me take it out. I hope you guys are benefiting. This is the revision session for grade 10 mathematics. So if you are doing grade 10, guys, this is the time to do your revision. 1.3, 3 marks. It says what here? Determine the value of d if 3x plus 2 is a factor of 6x squared plus dx plus 10. Let me write that one. I think it was interesting, this one. 6x squared plus dx, and then what we have, minus 10. So this is what we have. And then they're saying, when you factorize, determine the value of d if this 3x plus 2 is a factor. So what they're trying to say here is like this. When you do this, okay, and you do this, so one of the factors is what? 3x plus 2. That's what they're saying, guys. 3x, see, plus 2 is one of the factors. So for you guys who like factorizing like this, you say, me, I would have struggled there. But it's sometimes easier though to go about it here, because they've already given me the first factor in a way. To go for the second factor, I can see this, I need a 10. Look at this. I need a 10. So to get a 10, here, I need a 5. So I'll put a 5 there. Because 2 times 5, that is the last number. Remember, when you're multiplying, you will multiply the last one. This, you will multiply that. Are you with me? But I need a negative 10, which means negative also 5, because that is positive 2. At the same time, I come here to say 3x. I need the number there to give me a 6, because I will have to multiply this one times this one there to get what? A 6. So which means it can only be what? It can only be 2, guys. It can only be 2. So here I've got what? 2, and it's 2 what? It's 2x, you see? So that's the answer. It wasn't bad, but no, that's not the answer, sorry. We've got 3x plus 2, but that's the factorized version. And then you've got 2x minus 5. You can expand this, you can open this, so that you can see that it means it's actually the same. When you open it up, remember when you open this bracket, so what we have, it's this one times this, and that times that, and this times that. Let's open it up. So if we've got 3 times 3, it's 6x squared. Actually, that's what I'm going to do. Let me not open that. That's what I'm actually going to do. Let's open it up here. This times this, this times this, this times this, the FOIL method. I hope here I didn't make an error, NB. Just check it out. Maybe I was doing the wrong FOIL method. So let's open it up. 3x times 3x, what do I have? We've got 6x squared. And then 3x times this, I've got minus 15x. See? Then 2 times 2 is plus 4x, and 2 times minus 5 is minus 10. And then I've got equal to 6x squared, then minus 15 plus this is negative 11x minus 10. You see? So if I bring in what they said here, they said it must be what? It must be 6x squared plus dx minus 10. So what is d? Because the question is determine the value. Determine the what? The value of d. So what's the value of d? Compare, guys, compare. You can see here 6 is 6, x squared is x squared, minus 11 is d, x is x. Therefore, what is d? D is equal to negative 11. You get that answer? 3 marks. Difficult, guys? Not really, but it just needed you to apply a little bit of, a little bit of thinking, so that you can be able to find your way and navigate your way. Alright, so this was question 1. I know, as I say, it is taking long, but I have to do question 2 and 3 in this same session. You have to stay put. Watch it in bits, remember. Now we're in equations. Question 2. Question 2 is not going to be difficult. I'm just going to be doing quickly. So for x, they gave you this one. 3x minus 1 and x plus 2. This is equal to 0. Guys, already it's done. Don't be tempted to open the bracket. They have factorized it for you. You say either 3x minus 1 equal to 0 or x plus 2 is equal to 0. It's done. Then take 1 to the other side. We've got 3x is equal to what? 3x is equal to positive, negative 1 becomes positive 1. Now is 3x. What is it that you don't want there? It's a 3. It's like 3, guys, times x is equal to 1. That's what you're having. You don't want that 3. The opposite of multiplication is division. You divide by 3. What you do on the left, you do on the right. So that's how you just do that. I know it looks stupid, but that's it. So it's 1 over 3. And then on the other side, it's not difficult. Take x to the other, 2 to the other side. X is equal to positive 2 becomes simple negative 2. That's the final answer. You don't need to do anything extra. This was basic. This was standard. We're not going to do much there. There is the question. 2.1.2, 3 marks. This one, we can look at it in a bit of a different light. This is 2.1.2. Okay, let's write that. It says 3 to the power of x minus 2 times what? 3 to the power of x minus 1 is equal to 3. Okay, let's solve for x here. How do we do it? Alright, I say that here, guys, it's very important to remember this law. Remember, if they give you this law to say a to the power of m plus n, the laws of exponents, what is it? It's a to the power of m times a to the power of n. Still remember this law? Now, if I write it like this from right to left, if I say a to the power of, actually like that, let me leave it like that, just like that. That's what I'm gonna do here. That's what I'm gonna do on this part. You see? So let's continue. So this is gonna be 3 to the power of x. So I'm gonna split that minus 2 dot 3 to the power of, like I did, m plus n. To me it's x minus 1. So it's 3 to the power of x times 3 to the power of negative 1. You see that? Is equal to 3. I just used that rule. Why am I doing it? Because I want to factorize this out so that it becomes the common thing. So I take it out as 3 to the exponent x. You see? Then open a bracket. Remember, when you're factorizing, it's more like you're dividing. So what is happening is you're saying this one into this one. It goes once. You see? So that's what you have as 1 minus. Again, you are saying this one into the second one is minus 2 times this. So it's what is left, minus 2 and that. So let's write that as minus 2 times, it goes once, remember, 1 times 3 to the power of negative 1. You can ignore that 1, you see, is equal to 3. Don't forget there is a negative 1 there. And then we continue, 3 to the exponent x, bracket, we can use a calculator there so that we just don't get ourselves confused. It's 1 minus 2 times 1 times 3 to the exponent negative 1. It gives us 1 over 3. So this is 1 over 3 there. See that? Is equal to 3. What do you do? It's up to you. When I do, you can divide by 1 over 3. Remember this thing I told you of multiplying. So you can also divide as a fraction. You just need to be careful. Cancel there, cancel there. So what do you have? You have 3 to the exponent x is equal to, look how I do on the calculator, please just don't do this, do this. You press that and you press that like that. No, what you're doing is press the fraction, on top you have 3, put 3, go down, at the bottom it's a fraction, press the fraction. That's where you've got 1 over 3 as a fraction. If you make an error, you get things wrong. There is a 9. So here you've got 9. Now you need to remember 9 is 3 squared. So 3 to the exponent x is equal to 3 squared. When the bases are the same, we can say therefore x is equal to what? 2. The bases are the same. This you could have done it differently and said from here, if you wanted to do it differently, you could have said, where is it? From, I just want to see, from here to say 3 to the power of x times, remember 1 over 3 is 3 to the power of negative 1 is equal to 3. You could have done that here. This 1 over 3 is 3 to the power negative 1. You can test with the calculator. So now, same base, you add 3 to the power of x minus 1 is equal to 3. Now 3 is same as 3 to the power of 1. This is power 1. Same base, so you can say x minus 1 is equal to 1. And then after that, we are solving for x. Take 1 to the other side. Negative 1 becomes positive, which is 1 plus 1, then x is equal to 2. It's up to you how you want to do it. But the answers are the same. Alright, so let's take this off and move on to the next one. Alright, now, which one is it? 2.2, 3 marks. This is what you're given. Let's see what it gives us. 3 marks, inequalities. Okay, I didn't read that. Solve for x, I'm too fast now. Solve for x in the inequality. Usually, it's solving for x, but there is a next part. Write down the number of integers that will satisfy this inequality. Here we're solving for x, so I almost missed the other one. So it's what? We're looking at 2.2.1. When you're solving for x, I've got minus 1 is less than or equal to 1 minus 2x, right, over 3, which is less than 5. So minus 1 is less than or equal to 1 minus that, which is less than 5. What do we do first? Deal with 1. It's positive. Remember, this is more like an equal sign. This is more like an equal sign. So what you do, take 1 to the other side. And when you do that, 1 also goes to the other side. So this is how you do it. Minus 1 becomes minus 1. Positive 1 jumps the equal sign to become minus 1. So when it's like that, it's gone. Is less than or equal to negative 2x over 3, which is less than, again, is 5. Remember that positive 1 becomes minus 1. Are you with me, guys? Then you simplify this to become minus 1 minus 1 is negative 2 is less than or equal to minus 2x over 3. I'll leave a space there, is less than or equal to 4. What do you do next? You don't want that 3. You multiply by 3, multiply by 3. Each and every part, do the same thing because these are like equal signs. So what you do on this other side, you do on the other side. Okay, so when you multiply by 3, what do you do? Cancel there, so that you're left with minus 2x. But this other side, 3 times this, negative 6 is less than or equal to negative 2x is less than 12. Are you with me? Continue. We're still continuing. Now it's minus 2 times. There is a times x. What's the opposite of times? Is division. So here you're gonna divide by negative 2, but don't forget each side negative 2, each side negative 2. In inequalities, when you are dividing, the signs change. So look at it. It's that cancels, is fine. 2 into that is 3. So it's 3. But look at the signs. Look at the signs. I'm going to change also the signs. that faces this way now. And then, of course, minus 2 cancel that, so that you've got what? Your x. Now look at the sign again. It changes. And then the obvious one, negative 2 there, it's negative 6. That remains. So here we've got what? Negative 6. You see, that is what you have. It's difficult to read like this. It's more like you're saying 3 is greater than or equal to x is greater than or equal to minus 6. But we can write it the other way around. You can do it like this. Minus 6 is less than x. You are writing it going this way. Is less than or equal to 3. This is the most standard version you have. Always use it like that. Minus 6 is less than x is less than 3. So in a way, if I can say have a number line here, have a number line like this. So your number line starts from what? From minus 6. It ends in what? It's ending 3. So it's more like you're saying I've got that and I've got that. Because that is shaded, you share it here because it's equal to, and then you can join the lines. You see, that's what you're having if you still remember that. And then the question says write down the number of integers that will satisfy the inequality 1. Integers meaning what are the numbers between minus 6 and what? And 3. Remember, minus 6 is not included. So here we have minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2. So if they are saying let's write the number, write down the number of integers. These are the ones. Here, from this one to this one. So how many? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So equal to 9 integers. Okay, there are 9 of them. Right. So let's move on. Let me just take this off, and so that I can be able to work more again on this. Sorry about that. Let's take it off, and then yes, everything is off, but let's do this. 2.3. Solve for x and y simultaneously, but it's simultaneously. 5 marks. Alright, just gonna do it in 2 parts, the elimination and the substitution. I always prefer the elimination, but I'll also give you the substitution. Okay, actually it's the substitution that is preferred because it takes you further to the other grades. Okay, so look at this. So we've got what? X minus y equal to 4. We call that equation 1. And then x over 5 plus y over 2 equal to 5. And this is called equation 2. Always remember that. Just name them. X minus y is equal to 4. Correct? X over 5 plus that. Alright, guys, let me take this far. Let's take this just far. Let's work it on a plain space. So this is what I'm having. I'm just going to do it in 2 parts. This is what I'm having. From here, the problem I'm having is the second one. I need to make it flat. Take rid of the fraction, and you can see the common denominator here. The number that goes into 5 and 2 is 10. So we can multiply here this times 10 times 10 times 10. You see, so that we can just that. So 5 into 10 is 2. So what do you have? You've got your 2x plus 2 into 10 is 5. So it's 5y is equal to 5 times 10 is 50. Okay, we can call this our equation 3. Okay, then if it's our equation 3, let me bring equation 1, which is x minus y is equal to 4. This is equation 1. Now I can, as I said, I'm going to use the first method is elimination. It's not preferred, but it's fine. So in the elimination method, you look at this. You ask equation 1, let's eliminate x. So I'm gonna multiply by 2. So that equation 1 becomes what? It becomes, let me change color here. It becomes 2 times x, it's 2x. 2 times y minus 2y is equal to 2 times 4 is equal to 8. Let's call this equation 4. See? Then I'm bringing in equation 3, which is what? Let's maintain the main color now. 2x plus 5y is equal to 50. This is equation 3. See this? So that's when I call elimination, because I'm going to eliminate x. Do this. And then here I'm going to say equation 4 minus equation 3. See? So put a minus there. So what do? We continue. 2x minus 2x, this will cancel. Minus 2y minus 5y. See? Minus 2y minus 5y is equal to 8 minus 50. 8 minus 50. Minus 2y minus this is minus 7y is equal to minus 42. This is 42. Okay guys, use your calculator there. I'm not going to do that. Divide by negative 7, divide by negative 7. If you do that, y is equal to 7, negative 7 into 42 is 6. You need to know a times table also, but use a calculator, okay, to verify. So now I know my y is 6. I can choose my equation 1, x minus y is equal to 4. So I can go in and say into 1, which is x minus y is equal to 4. But I know x, I mean y is 6. X minus 6 is equal to 4. Take 6 to the other side. X is equal to 4 plus 6, which is equal to, error there, x is equal to 10. So when you're writing it, therefore, x is equal to 10, y is equal to 6. This becomes the final answer. But as I said, it's up to you. You can come in and use, instead of elimination, we can come here and say substitution. Substitution method. So we already know equation 1, x minus y is equal to 4. Equation 1, we maintain equation 3. I'm not going to write equation 2 because the same step you're going to do. 2x plus 5y. Okay, from equation 1, what we do, I can make x the subject. Take x the side. So it's going to be x is equal to 4. Now minus y becomes plus y. This becomes equation, I'll call it equation 3 because this was our, okay, I'll call it equation 4. Here now, it's going to be equation 4. Because we already have equation 3, which is that one, 2x plus 5y is equal to 50. 2x plus 5y equal to what? 50. This is equation what? 3. So where there is x, I substitute for what? For 4 plus y. So it's 2 bracket. See where there is x is 4 plus y. You see that? And then plus 5y is equal to 50. Still a good method. Now you open up 2 times 4, 2 times y. 2 times 4 is 8, plus 2 times y is 2y, plus what? 5y is equal to 50. And then you continue. This is the most preferred, by the way. So 2y plus 5y, 7y is equal to 50 minus 8. So 7y is equal to 42. You divide by 7. So what is y? Y is equal to 6. And then you come back here on equation 4. So you can come here and say into 4. What is it? X is equal to 4 plus y. But y is equal to 6. We just got y here. See? So then you continue to say what is x? X is equal to 4 plus 6. and x is equal to 10. You see, this was the simpler versions of substitution or elimination, guys. It's up to you. It's up to you how you want to deal with these. I have to take this off. Remember, pause the video and go through it again and again and again and again. Oh, this was the end. 2.3. That's that. Now we are looking at the last one. Question 3.1. This is what? These sequences. It's also something that is not going to take us much longer, I hope. Says question number 3 here. Also, some students get confused here, but let's look at this. Your friends Zane and Letty have been trying to solve an exercise based on the following sequence. C 2, 6, 10, 14. Letty says Tn is that, and Zane says Tn is that. Who is right? Use algebra to justify your answer. Now, let's focus. Letty is already fine. Let's focus on Zane. Is what? What is Zane? 4n minus 1. So Tn, let's focus on Zane here. Zane, it's Tn is equal to what? 4 into n minus 1. 4 into n minus 1. And then what? Plus 2. You see? Let's simplify this. Tn is equal to, open the bracket, this and this. So we have got 4n minus 4, and then after that plus 2. So what is Tn? Which is equal to 4n minus 2. So this is Zane. What was Letty? Letty was what? Letty had Tn is equal to, also look at this, 4n minus 2. 4n minus 2. So these guys, you see, they're all the same. So the question is, who is right? Use algebra to justify your answer. You can now conclude, say, therefore both are right. Both are correct. Both are correct. Both of them, because it simplifies to the same. You see, use algebra. Or if you had a challenge, what you could have done if you were challenged on this, you could have said it, you could have put it like this. But they were still gonna mark you, okay? They were still gonna mark you. So what are you gonna do? Okay, come on. You're gonna take Zane here. Divide this, have Zane. What is Zane? We say Tn is equal to, was it 4? What was Zane? 4n minus 1 plus 2. Right? Plus 2. And then Letty. Let me use something different for Letty. Letty was Tn is equal to 4n what? 4n minus 2. I'm just trying to show you it's still algebra to me. Now you go and say here, we maintain the pen here. T1 is equal to 4, 1 minus 1 plus 2. Okay, you get answer. Then you say T2 is equal to 4, 2 minus 1 plus 2. And then you get answer. Okay, let's get answer there so that we don't have it here. Let's get answer here. And then T3 is equal to 4, 3 minus 1 plus 2. And then T4 is equal to 4. We can end there. 4 minus 1 plus 2. Now let's use a calculator. We're going to use a calculator to do this. So it's 4, 1 minus 1, what? Plus 2. Let's keep these answers in mind. The first one is 2. I play back. The first one is 2. The other one is 6. After 6, after that I put a 3. Is 2, 6, 10. Let's play back. 2, 6, 10. Now the next one is 4. 2, 6, 10, 14. So we have got 2, 6, 10, 14. Now let's go to Leti. We do the same thing with Leti. So it's T1 is equal to 4 into 1. That's what you do. Minus 2. Which is equal to 4 minus 2 is 2. T2 is equal to 4 into 2 minus 2, which is 4 times 2, 8 minus 2, it's 6. T3, which is equal to 4 into 3 minus 2. Now what is 12 minus 2? It's 10. And T4 is equal to 4 into 4 minus 2. Now what is 4 times 4? 16 minus 2, it's 14. So you can therefore say, therefore, here, you see, they've got the same thing. Therefore, both Leti and Zain produce the same sequence. The same sequence. And both are correct. You understand? It's still algebra to me. It looks long, but it's still algebra. If you are stranded, okay? If you are stranded. If you were stranded. But the simple one I showed you. And then says determine the 27th term of the secant. Now 27, use the simple one for Leti, which is Tn. For Leti, it was 4n minus 2. Now T27, the 27th term is T27, is equal to 4 into 27 minus 2. Remember how we've been doing this, and then the calculator simple can solve it for you, and you can find the final answer there. So you've got 4 into what? 27 minus 2, and then you get the answer 106. That is T27. Alright, so that is that, guys. It mustn't be difficult. Moving on. Let's make it the original size. It says here 2 marks. Consider the following sequence: minus 3, 2, 7, 12, 17. Determine the nth term. Okay, nth term of the sequence. I don't know if this is. I'm gonna use the formula here, and I'm going to use different method. I'm going to show you different method if you are stranded here. 3, 2, 7, 12, and 17. Let's take this and play around this a little bit. Let's play around this, guys. These are sequences and series. So let's play around this. I just want to play around this a bit. Give me a bit of a time. I know you're tired. I just want to space them apart. I just want to space them apart and apart. Look at this. When you're given like this is what you do. You call it this your T1, term 1, T2, term 2, T3, term 3, T4, term 4, and T5, term 5. So this is what you do. You are like saying this. You do this, you do this, you do this, you do that, you do that, you do that. I think you have done it already in school, remember? So we are saying T2 minus T1, meaning 3 minus minus 2. You see? If it's confusing you now, use a calculator. Okay? So, because there is this negative one, so sometimes it can just trick you. But if you use a calculator, it will be what? 2 minus 3. See that? What we have? 5. You see? So be careful there. And then 7 minus 2. You see? This becomes easy. 12 minus 7. So this number will always, we call it the constant. Constant. Now, if you want to call the simpler root, I repeat, if you want to call the simpler root, this is what you have. The general formula here. General formula. Here is Tn is equal to an plus b. This will just give you answer fast. So what is your A? A is equal to this constant, the number that is not changing. So here you've got A is equal to 5. So when you write it, what is your Tn? Tn is equal to, where there is A is 5. It's 5n plus B. And then you come here, in this one you've got A plus B equal to this number. Are you seeing that? So you come here and say, okay, A, let's use this one, A plus B equal to that first number. It must be T1, which is minus 3. Okay, but we know A, it's 5 plus B equal to minus 3. Take 5 to the other side. What do you have? You have got what? B is equal to minus 3, positive 5 is minus 5. So B is equal to minus 8. See that? Then you know what is your Tn now. This means here, we can then conclude and say our Tn there. Tn is equal to, you know our A, which is what? 5, and our B is minus 8. There it is. You can test it, and it's easy to test it. You can say, I want to test with 4. So you're going to say here, let me try T4. It must give us 12. Is equal to 5, 4 minus 8, which is equal to 5 times 4. It's 20 minus 8. 20 minus 8 is what? It's 12. See? Then you know this is correct. That's the simplest way you can go about it, the formula. Okay? Now, I just want to show you something. I hope it's not going to confuse you. Look at this. If I remove this nicely and take it off nicely like this, and also I take this off nicely, this, I just don't, okay, let me do this. Yes, I want to show you something. I can work to T0. I'm going to use a different one. If let's say I want T0, how can I go to T0? To go to T0, let's go backwards. Look at this. I can start from T5. Now pay attention, It's 17 minus 5, I get 12. It's 12 minus 5, I get 7. It's 7 minus 5, I get 2. It's 2 minus 5, take a calculator, 2 minus 5, I get minus 3. So I can come here now and say, go here, I will still get a 5 here. You agree with me because it doesn't change. So it will be same thing, I need a number there. Here, I need a number. Okay, I'll put it back. I need a number. 5 won't change. So as I said, let me continue. Let's start from here. 7 minus 5 is 2. 2 minus 5 is minus 3. Minus 3 minus 5. It will give me a number here. Use a calculator. Minus 3 minus 5 is minus 8. Now, I can focus on this one here. And my formula is there. Tn is equal to what? 5n minus 8. If you grow it back to what? From T0, from T1 to T0, you'll get your answer there. It will be that, you put n there, minus 8. That's another way of doing it. Now, let's say, I hope you guys are fine. Let's say you want to do it, you're stranded on those two options. Let's say you're just stranded, but still, you just want to solve it, In grade 9, let's use the grade 9 method. Let me write that sequence. Minus 3, 2. Let's use the grade 9 method. minus 3, and then we've got 2, and then 2 plus 5, 7, 7 plus 5, it's 12, 12 plus 5, it's 17. 3, 2, 7, 12, 17. 3, 2, 7, 12. Let's say you are here. You want to use the grade what? The grade 9, because grade 9 doesn't use a formula. So let's use that. So it still works. T1, T2, T3, T4, T5. Let's say you still remember that method. Look at this. It still doesn't matter. You do the same thing here. We got 5, we got 5, we got 5, and we got 5. Still remember that. We're separating to say T2 minus T1, T3 minus T2, 7 minus 2, 5, 12 minus 7, 5, 17 minus 12, 5. Are you with me? Now, we look at it like this. We start from T. Let's say, remember here, we are saying T1 is equal to 5 is always our constant. So it's 5, 1, right? And then I'll say what? Minus 3. Start with that one, minus 3. And then I say what? T2 is equal to 5, 2, I maintain minus 3. And then I continue. Where did I get minus 3? There is minus 3. Where did I get 5? There is 5. So I said 5, 1, because it was T1. 5, 1 minus 3. So I used this one. I used this. I say, okay. So here, if I get an answer, what is the answer? 5 minus 3, I get a 2. 10 minus 3, I get 7. T3 is equal to 5, 3, I maintain it, minus 3, equal to, what is 15 minus 3? It's 12. And then T4 is equal to 5, 4 minus 3. Now what is 20 minus 3? It's 17. Now pay attention. These numbers are there, but something is wrong. Because if you look at it, my T1 is supposed to be minus 3, but my T1 is what? My T1 here is a 2. So I can come here and say, okay, let's work it like this. If I want my T2 to become my T2, I can come here and say T2, so that it becomes my T2 is equal to 5. And then here, where there is 2, I say, my T, yes, 2 minus 1. What do I have? I have got what? For 2 there, it will become same number, 5, 2 minus 1, but let's not forget minus 3. What does it give me? Remember, it gave me 7. And then, if I say my T3, so to maintain, it will be 5, 3, minus 1, minus 3, and then it gave me what? 12. And then my T4, it is going to be 5, you see, 4 minus 1, I'm maintaining, where there is 3 now is 3, where there is 4 is 4, so it's like that, minus 3 is equal to 17. So I can come here and say Tn is equal to 5, n minus 1, minus 3. Then when you open this bracket and open this bracket, it is going to be equal to 5 times n, 5n, minus 5 minus 3. You see? And then it becomes what? 5n minus 8. That becomes your Tn, which is similar to what we got, just that we erased it. It was 5n minus 8. Alright. Well, this is the longer one, of course, but if you remember the formula one, you can play around the formula one. Guys, we are ending up here. 2.2.2. Okay. It says determine the 52nd number to end in a 7. this one, what are they saying? Determine the 52nd number to end in a 7. The 52nd number will end in a 7, in a way, if you look at it from here, it ends in a 7. So like this number ends in a 7. This number ends in a 7. I think we can look at it like this. Let me write this sequence again. It was a tricky question there. 3, 2, 7, 12, 17. It was a tricky question. So this one ends in a 7, this one in a 7. Remember, it's T1, T2, T3, T4, T5. In a way I can try to predict. So T1, T2, and then T3. From T2 to T3, you see 3 is a 7, 4, 5 is a 7. I can say T6 and then say T7. Remember, what is Tn? Tn is 5n minus 8. Now let's come to T6. It's what? 5, 6 minus 8. Let's come to T7. Is equal to 5, 7 minus 8. I'm going to use a calculator for both of them. Alright. So let's start with T6. 5, 6 minus 8. 22. Play back. With 7, you see 27. So here it's what? It's 22. And here it's what? 27. So you can predict in every 2. Look at this. We can literally take out from here, 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 here. We can actually go to T9. Let's try T9. T9 will be 5, 9 minus 8. You see? Then I can predict T11. You see what's happening? Then from 11, what do you think? It's what? It's 13. So you see all these numbers are ending with a 7. So I can actually come up with a sequence to say I've got 7, 17, 27, 37. This becomes my T1, my T2, my T3, my T4. You see what is happening? I do this, T2 minus T1, 10. Do that, 27 minus this, 10. Do that, 37 minus this, 10. From here, remember what I said? I said there is the formula version. I'm going to use it because it's quicker. In the formula version, what did I say? I said A is equal to third. Remember I said Tn is equal to an plus b. And then 7 here is a plus b equal to this one. Okay, so now when you work it out, you've got this. Tn is equal to a, which is 10n plus b. Then you come here and say, but a plus b is equal to 7. And then a is 10. 10 plus b equal to 7. Take 10 to the other side. b is 7 minus 10, which is equal to negative 3. So what is our Tn? Our Tn becomes 10n minus 3. Are you seeing that? Then this question, it was a bit tricky. It says determine the 52nd term number to end with a 7. Now the 52nd, we come here and say T52. It will be 10, 52 minus 3. Alright, it was a bit tricky. I don't want to lie, for grade 10. This is your high-end question. So it becomes 10, 52 minus 3. Then becomes 517. You see, this number also ends with a 7. It was a bit trickier, not making sense in a way to me. But yeah, that is that, because I hope it's happy because determine the 50-second term. If we put 50-second here, for example, we say t, the previous one was 5n minus 8. We say t52. 50 what? Yes, 52 is equal to 552 minus 8. I'm just trying to show you the obvious. Here, if we say, sorry about that, if we say 552 minus 8, you see it won't give us a 7 as the end number, so it becomes a problem there. Okay, so this one doesn't allow you. It is that one. Guys, we've come to the end of our session. What's next? Question number 4. I'm gonna deal with it for you, and you don't want to miss out. It's what? Functions. There, you see, I'm gonna do it in the next session. Question number 4, functions, 19 marks, guys. Question number 5, functions, 10 marks. Already 29 marks. Then after that, question number what? So it was question number 4, question number 5, question number 6, financial maths, and question number 7, probability. So let's do that. Join me in the next lesson. So here, in a way, I was focusing on algebra. Okay, so guys, we've come to the end of our lesson. If you are benefiting, share the channel, like the channel, and remember to leave your comment. We have come to the end of our lesson. My name is Confident. Thank you.